Okay, today we are going to talk about graphing inequalities. Some of this is review, and some of it's brand new. So we're going to look at how to solve inequalities, how to graph inequalities. We're going to look at set notation and interval notation. Okay, so remember that just an inequality is a mathematical sentence that's built from expressions using one of the order symbols, and I'm actually going to add this order symbol for not equal to. And we solve them like equations, except when you multiply or divide both sides by a negative, you're going to flip the order symbol. So we have set notation and we have interval notation. Set notation is what you have been doing all along, and you should know those symbols. You have greater than, greater than or equal to with a line underneath it, and it means that that point is included, whatever it would be, less than or equal to. Now we have set notation, okay, or interval notation, which is a little bit different. In interval notation, if I have a parenthesis, this means a point is not included. Okay. If I have a brace or a bracket, it means that a point is included in the solution. So this is like the less than or equal to. This is like the greater than. Okay. So when I look at interval notation, also in interval notation, I'm going to list from smallest to largest. Okay. Negative infinity always being the smallest and positive infinity being the largest. It looks like I missed a negative sign here. So when I have this greater than, okay, it means it's going from some point off to positive infinity, some point off to positive infinity, and so on and so forth. So let's look at some examples of what that kind of looks like. So I've got some graphs and I've got some notations. So x is greater than -2. In interval notation, that looks like -2 to positive infinity. And with infinities, we always use the parentheses. So if I'm going to graph that, that's an open circle on -2 and an arrow going to my right. Possible solutions could be -1, it could be 0, it could be 1.5, it can actually be -1.999. It's going to get as close as possible to -2, but not include -2. Okay. My interval notation here says that whatever it is goes from -infinity to +2. +2 is included because of the brace. So I've got a closed circle and -infinity. So this is going to be a less than. So x is less than or equal to 2. So some possible solutions could be 2, it could be 0, it could be a half, it could be -100. But anything that's less than 2 is included in our solution set. Okay. If I look at the next graph, I've got an open circle at 1 and my arrow goes to the left, so it's going to be less than. So my solutions could be 0, -1, -1.5, anything that's less than 1, but 1 is not included. So I would write that as x is less than 1. In interval notation, -infinity with parentheses to 1 with parentheses, because that parentheses means that it's not included, And we always use parentheses with negative infinity. Okay. Now, r not equal to 2 is kind of weird in interval notation. I'm not going to expect that you know that. But what it is we're saying it goes from negative infinity to 2. And we say union with 2 to positive infinity. So that's what it would look like in interval notation. The graph would be an open circle on 2 and then arrows going in both ways. So now our solutions would be anything but 2. So we could pick any number we wanted, and that would be part of our solution set. Our last example has a closed circle on 0 and going to the right, so I know that's going to be x is greater than 0. I'm going to go from 0 and it's included, so I use that bracket, to positive infinity and I close it. And so solutions could be 0, it could be 10, it could be 100 and 23 hundredths, it could be whatever we want it to be. Remember, it doesn't have to be integers. Right, so let's look at how we're going to solve. Now I said that we're going to solve the same way we would solve an equation. So this is just like a one-step equation. So I'm going to add 12 to both sides, and I'm going to get x is greater than 26. Okay. So when you go to graph, I would like to see 3, I'm not real picky, but I would like to see 3 numbers on either side, 25, 26, 27. Okay, an open circle on 26 with the arrows going to the right. Set notation is x is greater than 26. Okay, interval, we're going from 26, it's not included, to positive infinity. And I could pick anything that's greater than 26 to be in that solution set. So 27 and 28 would work. Let's look at the next example. That less than or equal to, the equal to is kind of light, but this is addition, so I'm going to subtract 16 from both sides, and I'm going to get 8 is less than or equal to x. Now, I can flip it around so it's x is greater than or equal to 8. And the nice thing about that, if I flip it around so that my x, or my variable, is on the left side, then my arrow when I go to graph is going to be the same. So if I would go 7, 8, and 9, okay, I've got a solid circle filled in because 8 is included. And my arrow goes then to the right because I want everything that's greater than 8. So set notation, x is greater than or equal to 8. Interval notation, 8's included, so I use a bracket, and I'm going off to positive infinity. And we could include 8, and we could include anything larger than 8. You can pick whatever number you want as long as it's bigger than 8. All right. Now we're multiplying and dividing, so we need to be careful because if we are multiplying or dividing both sides or all the way through an equation by a negative sign, we're going to flip the order symbol. Now in this case, this is 2 times x divided by negative 12, so we're dividing everything by a positive 2, so we don't flip the order symbol, so I'm going to get x is greater than negative 6. Looks like I picked all greater thans for examples. I don't know how that happened. All right, so if I pick points on either side, negative 7, negative 6, negative 5, an open circle on negative 6, and the arrow going to the right. So set notation, x is greater than negative 6, interval, a parenthesis because negative 6 isn't included, and infinity, parentheses. So negative 5 could be part of my set. Negative 5.75 could be part of my set. We can get as close as we want to negative 5, or negative 6, but we can't go below it. All right. Last example. I'm going to multiply, because this is negative 1/2, both sides by positive or negative 2. When I do that, I have to remember to flip this order symbol, so it's going to be less than or equal to. So I get negative 12 is less than or equal to x. And then if I turn it around, x is greater than or equal to negative 12. So negative 13, negative 12, negative 11, closed circle, an arrow going in that direction. So in set notation, x greater than or equal to negative 12, interval, it's included, so it is a bracket negative 12 and infinity 0. Now, just like I told you when we were doing ordered pairs and we were doing functions, different things, different symbols mean different things in math, so you need to make sure that you have your symbols right. Negative 12 would be included in this, and I don't know, 0. Even though I have the recap next, I just want to say one more thing. I guess I can do that part of my recap. When I'm talking about set notation or interval notation, when I have x is less than something, 5 since none of our examples, my interval notation would be from negative infinity, okay, to positive 5. So the reason that is because, okay, I'm going to go this way. This is negative, not negative 8, negative infinity, always all the way down here, positive infinity all the way up here. And we don't need the plus sign, so we have positive infinity. So remember that solving an inequality is very much like solving an equation, and except for when we multiply or divide both sides by negative, you need to flip the order sign. I'm going to warn you now that in this unit with the solving equations, I've put a lot of fraction practice in here. So if you are struggling with fractions, please make sure that you get some help. Have a great day.